Okay, good morning, class.
Good morning, sir.
So at this point, you got your papers back. We're looking at the control test 1 of 2023, the paper that you guys have written. And at this point, you got your scripts back. Please ensure that all the questions was marked. Okay. Otherwise, you can do cross-reference now. Okay. I've sent the memo to the group. Have I sent the memo to the group? No. Okay, so I'm going to do that now. And the memo, a link to the memo will be found in the description box below. Okay. Right, you just need somebody to follow to ensure that I've not made any mistake. Okay. Alright, so question 1 says given you got cos of alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. The question says derive the formula sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. Okay, so you must use the given formula, which is cos alpha minus beta. Okay? So what we do is we work with the left hand side. So we say left hand side is equal to, now sine can be written as cos 90 minus alpha plus beta. Okay? I'm going to get rid of the bracket within. It's going to give me cos 90 minus alpha minus beta. So as you can see, you got that minus beta there. So alpha is then going to be 90 minus alpha. So if I take that into account, wherever I see alpha, I'm going to put 90 minus alpha. Okay, so then in other words, we have cos of 90 minus alpha, cos of beta, plus, remember that is alpha then, plus sine 90 minus alpha sine of beta. So 90 minus take us to the second quadrant, cos is positive, however it changes to sine alpha, cos beta, 90 minus first quadrant, so it will be plus, sine changes to cos alpha sine beta. That gets you 4 marks. Okay, I told you, we'll learn this, the derivation of these formulas. Most of you didn't get it right. I don't know. I think the more we do, the less you guys do. The more we give you for the paper, tell you learn this, learn that, the less you actually go learn. By the looks of it. In 1.2 we are given sine of 38 degrees equal to m. Without using a calculator, express the following in terms of m. Okay. So here we go. That is your 38 degrees. Sine stands for opposite over hypotenuse. So there's m. Hypotenuse, of course, is 1. If I apply Pythagoras, is 1 squared is equal to m squared plus your adjacent side squared. Your adjacent side is then equal to the square root of 1 minus m squared. Then, of course, this angle here can be worked out. So I say 180 minus 90 minus 38 degrees. That gives me 52 degrees. Okay. 52 degrees. Okay. So now let's look at 1.2.1. We know that there's all stations to Claremont. It's 180 degrees. So 218 is in the third quadrant. How do we get in the third quadrant? It's going to be sine of 180 plus 38 degrees. Okay, and the second quadrant sine, of course, is negative. Sine is negative, so it's negative sine 38 degrees. And sine of 38 is m, so the answer is negative m. Okay. we're looking at 1.2.2. We have sine of 68 degrees. So how can we link 38 to 68? We're going to say 30 plus 38. So that's going to become sine of 30 plus 38 degrees. So now that's your alpha and your beta angle. So now we're going to use the sine compound expansion. So that's going to be sine alpha cos beta plus sine beta cos alpha. Okay. So we have the 38 degree triangle. So the other triangle we need, of course, is the 30 degrees. So that's 30. So that's 1, 2. Sorry, that's 1, 2 root 3. Okay. So sine of 30 is half times cos of 38 is adjacent of hypotenuse. Is the square root of 1 minus m squared over 1 plus sine of 38, which is m. Okay. Sine of 38 is m times cos of 30, which is going to be the square root over the square root of 3 over 2. So as you can see, the denominator is the same throughout. So it's going to be 2 root 1 minus m squared plus root 3 m. That gets you 4 marks, people. Okay. People, the stuff's not going to come to you in an exam or as a revelation when you're in your final exam. You need to put in the time for these topics. Okay? It's not going to come to you just like it. You need to work it. People, in 1.3.1, you are given sine 45 minus x. They say expand and simplify the given expression. So this is again in the form of sine of alpha minus beta. So if I expand the expression, that will be sine alpha. Alpha in this case is 45 cos beta, which is x, minus cos 45 cos alpha sine beta, which is x, of course. Now, the square root of 45 is going to be 1 over square root 2 cos x minus 1 over square root 2 sine x. Or we could have written it as the root 2 over 2 cos x minus root 2 over root 2 sine x. That comes from the special triangle. Remembering that's 1, 1 root 2, so that is 45 degrees. Okay. Then in 1.3.2, the question then says, hence means to say, as use the previous answer, prove the identity. So of course, again, the left hand side is more complex. So left hand side is equal to that is your sine double angle, which is 2 sine alpha cos alpha, so it's 2 sine x cos x plus, now what we have is the sine for 45 minus x, that's what we have, okay? So that 2 on the outside must still be multiplied by it, and it is being squared, as you can see there. So that is 1 over root 2 cos x minus 1 over root 2 sine x. Okay, so that's simply going to be 2 sine x cos x plus. So I need to square out the binomial first, so it's 2 into. Square the first term, so 1 over root 2 squared is 1 over 2 cos x all squared. So it's the first term times the second term times 2. So 1 over root 2 cos x times 1 over root 2 sine x is going to be 1 over 2 sine x cos x. Times 2 is going to give you 2. No, times 2. That will be 1 over 2 sine x cos x times 2 is going to give you sine x cos x. Okay? Plus the last term squared, which is 1 over root 2 all squared, is 1 over 2 sine x all squared is sine squared x. Okay? So of course I'm going to get rid of the bracket here by multiplying this out. So it's going to become 2 sine x cos x plus half times 2 is 1, so it's cos squared x, minus 2 sine x cos x plus sine squared x. So of course I'm looking for like terms. So 2 sin x cos x cancel 2 sin x cos x. So I'm left with cos squared x plus sin squared x, which is equal to 1, which in turn is equal to our right hand side. Okay. The next question. We have said hence show that without the use of a calculator, that sin squared 15 is equal to 2 minus the square root of 3 over 4. Okay? So if we look at sin squared 15, sin 15 can be written as, so again this is an identity. So we say the left hand side is equal to sin. Now that's going to give you 30 minus 45 degrees minus 30 squared. And why am I using those values is because they are special angles. Okay. Now I'm going to go with the sign expansion as I had here. Just pull this up. Now I could use the sign expansion there if I like, but I've worked with the sign expansion here already. Can you see that? So in other words, this should simply be open brackets sine 45, which is 1 over root 2 cos of 30 minus, I'm taking it from here, minus 1 over root 2 sine of 30, and it has to be squared. Okay. But then again, if you look at this, this would have been an easier way, but I didn't pick it up earlier. That you see that is what it's equivalent to, and that's what it is equivalent to. Okay, but then this, I was hoping to make it equal to that line, but there's a 2 in front, so it's not going to apply it. Okay? But you could have picked it up at this point here already. But what I'll do is I'll just say, okay, the 30-degree triangle again comes into play. So it's 30, so it's 1, 2, root 3. So that is 1 over root 2 cos of 30, which is root 3 over 2, minus 1 over root 2, 1 over 2. As cos of 30 is a half. Which now gives us 2 root 2, as you can see the denominators are the same. The root 3 minus 1, and it has to be squared. So what I do is I have a binomial square in the numerator, so I square the first term. So the root of 3 all squared is going to give you 3 minus 2 root 3, and negative 1 squared is positive 1. I've just squared the top, the numerator. If I square the denominator, 2 squared is 4, and the square root of 2 squared is 2. So 3 plus 1 is 4, minus 2 root 3 over 8. And as you can see, 2 is a factor of all those terms there. So I divide throughout by 2. So I got 2 minus the square root of 3 over 4. And that is equal to the right hand side. Okay. So it is equal to the right hand side as proven there. Let's look at number 2. In question 2.1, we are given a negative angle, so what do? I add 362. Not so? So that is all stations to Plymouth. That's 180 degrees there. So if I add 360 to that, it becomes 360 minus theta. If I add 360. So 360 minus theta takes you to the fourth quadrant. Is cos positive and negative? It's positive. So it's positive cos theta times 180 minus, that takes us to the second quadrant. Tan is negative. Negative tan theta times 90 minus takes us to the first quadrant. Cos changes to sine of theta over 540. If I subtract 360 from it, I'm left with 180. 180 plus theta is in the third quadrant. Sine is negative, so it's negative sine theta times 180 minus, that takes us to the second quadrant. Sine is positive sine theta. So negative divided by negative is positive. Sine cancels sine. Now the tan can be written as sine over cos. So I got cos theta times sine theta over cos theta divided by sine theta. Now of course cos cancel cos, so I'm left with sine over sine, which is 1. I'm left with 1 dp. Okay? (2.2). We are given that cos of 2 theta plus cos theta over sine 2 theta minus sine theta is equal. Again, it's an identity. We need to prove the identity. So let's go. The left hand side is more complex. So if I look at the denominator, that is a definite. It goes into 2 sine theta cos theta minus sine theta. And in the denominator, I can take out sine theta as a common factor. Then I'm left with 2 cos theta minus 1. And as you look here on this side, we have a sine theta only. So that 2 cos theta minus 1 is going to cancel out somehow. Okay? So let's go to the numerator now. The cos 2 theta can be written as 1 of 3. So it's 2 cos 2 alpha with theta can be written as 2 cos square theta minus 1. 1 minus 2 sine square theta. And cos square theta minus sine square theta. Okay. Which one do we choose? Of course, it's a cos here only. So I choose the one dealing with cos. Okay, so that's going to give you 2 cos square theta. Theta minus 1. And I put there the cos theta. Why did I write it so? So it can be in the form of a trinomial. That's the idea. So if I replace cos with an x, it will be 2x squared plus x minus 1. It factorizes into 2x, x, 1 and 1, plus and minus. So if I see x, I put the cos. So it's 2 cos theta minus 1 and cos theta plus 1. And as you can see here, that will cancel. So what are we left with? Cos theta plus 1 over sine theta. And as you can see, it's equal to the right hand side. Okay. Then the question says, for which value of theta will the given identity be undefined? Just draw this identity down here. Which values of theta will the given identity be undefined? When is an identity undefined? Is when the denominator is equal to 0. That's also 0. So looking at that denominator here, it is where 2 sine theta cos theta minus sine theta is equal to 0. We factorize and work with this already. So we could have gone straight and say sine theta into 2 cos theta minus 1 is 0. We could have gone straight into that. Because we worked with it already. And in the same time, we will pick up that sine theta as well. So in other words, is we sine theta is equal to 0, or where 2 cos theta minus 1 is equal to 0. So cos theta is equal to a half. Okay? So we haven't answered the question yet. So we must set up the general solution for this, because why, it's not a restricted domain either. So we ask ourselves, okay, where sine equal to 0? Sine is 0 at 0 and 180, 360. So to represent that, we say x is equal to 0 plus k times 360, or 180 plus k times 360. But as we can see here, that this happens every 180 degrees. So you can just say 180 plus k times 180. Or we can just say 0 plus k times 180 is the same. Okay. On the other hand, my reference theta is equal to 60 degrees. If I say arc cos of a half, then the question is, in which quadrant is cos positive? So it's the first and fourth. So theta is equal to 60 in the first quadrant, in plus k times 360. Okay? Or I'm going to say 360 minus, which is 300 plus k times 360, or I could have just said minus 60. Okay, so it's plus minus 60 plus k times 360. Both would give you the full mark there. Okay, the memo, I think I wrote the other one. In question 3.1, so now we're going to geometry. I told you this diagram is coming, this proof is coming. They said 40% of you got it right. Sad. Okay? After I told you explicitly, it's coming. But the link to the proof will be found in the description box below. Let's look at 3.2. Question 3.2, we are told that in the diagram CD is a tangent to the circle at H. We are also told that AC is parallel to EF. Okay? So if this is a tangent, we know that H1 has to be equal to B2. Tanko theorem. And H3 is the same as G2. Tanko theorem. Okay? So that we must just keep in the back of our head that those angles are equal, of course. Okay? Alright, in our next lesson we will complete this memo. We will enjoy the rest of your day. Good morning, class. Please collect the papers, okay?